Do you see a record button bottom right?
Yes, yeah, it looks like it's recording now. Okay, so this is the weekly KEP review meeting for bucket provisioning APIs for SIG storage. And I guess first off, so I'm recording this to my device because I don't think I have a cloud drive to back up the Zoom.
Yep, that's what I do as well.
Okay, cool. And then I'll upload to YouTube and send the link up.
Sounds good. I can give you permission and all that for the Kubernetes SIG storage offline.
Great. Okay, cool. So we left off last week with kind of the hanging question of how to sort of dynamically represent existing object store buckets such that administrators don't have to create a bucket content object for every new connection that's made to that. The initial solution proposed that we kind of overload the bucket class. That doesn't really feel good to anybody. So Guy and Jeff and myself have been throwing around some ideas since then, and we have a different proposition. Before I share a screen here, I'm just going to describe it a little bit. So the idea with buckets is that they differ fundamentally from volumes in that they are globally accessible over the network so long as you're within that network, and they're naturally read-write many as opposed to volumes which are not. Now we're not familiar with why the one-to-one binding comes up with PVCs and PVs, why that's a mandated thing, but we don't think it's a good fit necessarily for buckets. At least we weren't able to think of a reason. We are very open to people pointing that out in critiques and comments. So our solution, and I'm going to go ahead and share screen here, sees the bucket content object being accessible from multiple bucket APIs. The fit for greenfield and brownfield seems to be pretty easy, and in terms of shareability, it would allow access from multiple namespaces, which I know in the volume and block and file world is typically a no-no. With buckets, we wanted to get the SIG's temperature on how they feel about this. Buckets normally are well, at least there's use cases where they are publicly reachable from the internet, from anywhere within a network. And to represent that sort of public access, it kind of makes sense that the bucket content represents that endpoint, and people just say they want to connect to that endpoint. So first off, can everyone see my screen clearly?
Yep.
Okay, so the way we re-envision this is that given a greenfield case, so I want to dynamically create a bucket. The user firstly creates their bucket object to reference a bucket class, so that remains the same. The backend bucket is provisioned, and a bucket content object is created for that, and references the bucket, and then is bound to the originating bucket API. So the sense of binding still exists in greenfield, but serves a slightly different purpose. Once created, bucket content objects can then be accessed by other namespaces in sort of a static binding way, where a bucket is created, the bucket content name is pre-filled out in that bucket object, and once done, automation can either create a config map in that namespace, or one of the other solutions that we've yet to touch on in how we get the data to the pod. So just as kind of an example what the API would look like, you have your originating / owning bucket. It has a reference to the bucket content. Bucket content has a back reference to the owning bucket. That's all set through automation. So follow-on buckets, accessor buckets, then reference this bucket directly to access this backing store. As part of cleanup, it requires a little figuring out. Generally, we think that the way object stores work is, if I own the bucket and I have people accessing the bucket, if I delete the bucket, then that, they lose access. It's my bucket. I can delete it if I need to. That should be represented in the Kubernetes layer as well with protections. So taking into account retain policy, so delete or or retain, where the backend bucket is the target of that. Should the owning bucket be deleted? If the retain policy is for retain, the bucket content would be deleted, but those who have access can still access that bucket, which is still reflective of how the real world, how this would represent the real world. If we're not deleting the bucket, or if we delete the bucket content, we're effectively disallowing more accessors to connect to that bucket, but we're not ripping it out from under workloads that may need it.
John, I have a question, John. It's my understanding that some providers don't support deleting a bucket that is not empty. So I guess if this is a very large bucket after a workflow is completed, now the responsibility will fall to the driver to perform the whole delete operation on the provider in the case that the release policy is delete.
Correct. Yeah. So the Kubernetes controller side automation is not going to be checking whether or not there are objects in there. If the driver does not support deleting while there's still data in there, then it's up to the workload to clear that out. Otherwise, if there's objects in there, it should return an error up to the bucket layer so that, we record the event. Users can see, can't delete because of X, Y, and Z. They can take the necessary actions. Otherwise, yeah, it's up to the driver.
Okay, so if the bucket can't be deleted, we still delete the reference and the objects, but I guess then it becomes a brownfield bucket if people try to assume it's going to get created again, right?
I'm sorry, that last part I didn't quite catch.
So if they delete the bucket, right? So and I guess we error out, we couldn't delete it, but we delete the bucket resource anyway and the bucket content. And then another bucket resource gets created, and a bucket content realizes that, well, the bucket already exists, so it cannot be created, right? So will that fall into the brownfield flow now? Where you had the assumption that you were going to create a bucket, but the bucket is pre-existing because it wasn't successfully deleted previous time.
Well, so in this case, the bucket content wouldn't be deleted, right? It would fail to delete, and therefore the representation of the bucket content would not be deleted. It would stick around and there would be an event saying, hey, I can't delete this thing.
Yeah,
okay.
Exactly. Yeah, as for verifying that bucket does or does not exist in the background, then that's not really something I think we want to check for, because that overlaps in a few different cases.
But my only concern will be that if someone's trying to do cleanup of a namespace and they cannot delete the bucket because bucket content has a reference to it, maybe if we release, if we ease that reference from bucket content back to bucket in case the bucket deletion goes, and we just leave bucket content alone, then the bucket resource can be deleted successfully now.
Yeah, true. So there's a couple of different ways to approach this. The first way that I've diagrammed here is kind of the one that was off the top of our heads. Another way to do it would be to, rather than set an owning bucket, manage bucket content cleanup via checking for owner or for references in the connections, right? So in our API objects, our user end API objects, if a delete occurs, we would check to see if anyone else references that bucket content. If no one else does, then it's safe to delete per the retain policy. If we can't delete because there's objects in there, again, then that's just that's an error and we can't delete. We're not going to clean it up, depending on the driver. So that was another way we had thought about maybe managing cleanup operations there.
A couple of questions, if I could there. First one, which is a bit of an aside, is this going to be handled through the CSI API, or are we looking at a new API extension here?
We're looking at a new API extension here.
Okay, I figured that. Good. Next one. And the next one is when we delete a bucket, what do we expect will happen in the actual object storage backend?
That is dependent on the retain policy that's defined in the bucket class, which will then be populated into the bucket content object. The way we've defined them thus far is we have to delete and retain. If delete is specified, then the Kubernetes automation will tell the driver to delete the bucket. Now, if the driver can't do that for reasons, then it returns those reasons back to Kubernetes and reports them. If it is retain, then the expectation is that we don't delete the bucket. We just delete the representation of the bucket in the cluster.
Good comment, but some content addressable storage systems allow establishment of a policy that prevents any form of deletion of the object that is stored there. What do we expect to be returned in that instance? The fact that it wasn't deleted, or that it was the delete operation was completed? Do you follow the question I'm asking?
Right.
Yeah.
So there's
You're
essentially
talking about warm, for example.
Yeah.
So I think that would make sense to configure the bucket class to not delete, right? I mean, if that's what the policy that you're provisioning, then the bucket class and the driver should configure that bucket not to delete and retain it, and that's it. And so I think it's a matter of defining policies, and we're just saying that there are multiple policies that needs to be maybe existing so that more use cases can be represented. And I think there's a policy of saying what happens when I delete the bucket resource in the namespace, and what happens when I delete the bucket content resource in the
so that's all. Yeah, admitted, that's all from the Kubernetes perspective. But what about what happens in the actual?
So that's the policy. The policy says what should we apply to the actual world when this is deleted. So a bucket content can have a retain policy saying I would like to retain the bucket when I'm deleted, or it can have a policy saying I would like to delete if empty, or it could have a policy saying I would like to delete including content, right?
Sure, and the question I'm asking is, what is sorry, I don't mean to cut across you, but if I may.
No, it's okay.
What if we set a policy that says it can be deleted, but the actual CAS backend says, no, our policy says don't do that?
So the driver should decide what to do then, if that's an error or not, but it's a matter of your driver.
Okay, got it. Thank you.
Right. Yeah, I think in all cases, we probably don't want to try and override what's going on in the backend policies, barring what the driver's written to do, because we don't have any control over that.
The retain policy just tells you what Cozy will do, what interface it will call. And it's still up to the driver to actually implement what it wants to implement.
So that's going to be at the vendor's discretion then?
Right. So it would be possible that Cozy calls the delete interface in S3 driver. And for whatever reason, that S3 driver decides I'm not actually going to delete this bucket.
Yep.
And returns success. It returns a nil error to us. Then that's it.
Yeah, we're done with it. Yeah.
Yeah.
Yeah. That's where my only concern will be actually decoupling bucket content reference to bucket, so that, I mean, I can understand the error happening on the driver, and keeping the bucket content, because now we need to keep some sort of, like, we created this bucket and it cannot go away. Like, we're gonna keep it, but the bucket resource can be now deleted itself, and then if it gets recreated again, I guess it will get recoupled with bucket content, and then that everything will go smoothly right from here.
So can I try to describe it, maybe? Because I have some idea of how it might look like. Sure. So let's say we create a bucket, and then the controller creates a bucket content. Because it's a greenfield case, we're asking for a new provisioning. And then the driver would create a bucket, done. We have a bucket bound to a bucket content. another namespace asks to bind to the same bucket content, and we bind it. Now, the original bucket gets deleted, right? And the bucket that provisioned was setting that it wants to delete the bucket content when it gets deleted, like an owner of the bucket. In that case, the controller would go and delete the bucket content, would apply the retain policy on the bucket. But in any case, that will make the other bucket, the second bucket from the second namespace, unbound, right? Because it cannot be bound to that bucket content, it doesn't exist. So essentially, this is just a named reference, which we are respecting also the owner as somebody that manages the lifecycle automatically of the bucket content for very owner greenfield cases, right? This is where this use case is more relevant.
Do we need to special case the owner?
Well, just if you want, so I think the reason for it is that, well, we don't have to be honest. I think that it's just a view of an application that might be an owner, complete owner of the data, rather than the administrator being the owner of the data. I'm not sure if that's more popular or less popular to think about it this way, but I think it makes some sense to give applications their own, bucket for objects that they can delete at the end.
Yeah, I guess when that happens, the second namespace with trying to access the same bucket wouldn't be as popular. I would like to imagine, I guess, unless you're running the same application in two different namespaces and they attempt to create the same bucket at the same time, then maybe we will run into this situation where two buckets are referencing the same bucket content, right? But
no, I think we can serialize it in the same cluster.
What do you mean by serializing it?
I mean, by making sure that there's no two bucket contents being created with the same data.
Oh no, yeah. That's not my concern. I actually like because on the design from last week, you had one bucket content for one bucket, and you said that was for MVP. Well, I don't know whoever wrote the document, and I like it that now we are reusing single bucket content to two buckets. But then again, I think it won't do any harm to decouple the ownership from bucket content and bucket, and just try to do our best effort to delete. But if it fails, we can just leave bucket content there, saying like, driver said I cannot get deleted, but then the bucket resource can still be deleted. So now like in your example, guy, the second bucket doesn't get unbounded, right? Doesn't stop working, right? Can still go on.
So that's another option we discussed, that we would actually do a reference. So we don't reference count, we just query to understand how many references are left at each point that we reconcile a bucket content. But we can reconcile a bucket content, discover that there's no other buckets referencing it just by querying, by label or something of that sort, and then decide that it's unreferenced, right? And should get released. So that's the shared pointer model for what we want to do. I think the other way to look at this is that there are different ways to manage buckets, and by that I mean there's either that it's a bucket managed by the application completely, and the lifecycle of the bucket is bound to the application, and or there's another model, which means that this is a data set, or there's the entire data set of this cluster is being trusted by the administrator to manage, and therefore buckets are only referencing things or provisioning things, but the administrator is the only one who's actually expiring things for good. Okay, so and then it has more auditing capabilities, perhaps backup, perhaps data protection, whatever the ways to configure more general policies can be applied in this level of bucket content.
So I wonder if you can get that without special casing the owner on your bucket object, right? If the way I'm imagining,
the attachment to the application, right? So
right. So basically, don't treat any of the applications as special. the first one that provisions it happens to be the one that'll end up creating the bucket content. And
Right.
if the bucket content is set to delete automatically, then whenever all the references, incoming references disappear, then the deletion happens. And so if
Right.
you have an application that wants to completely manage the life cycle of this thing, you should only have that application use the bucket content and nobody else. When you're done, you delete your reference and it'll delete the underlying content, and that way it'll simplify this design.
And so would we need a cleanup task to clean up the orphan bucket contents if it doesn't get deleted? You know, I like the idea of not being blocked on it, but we also don't want a bunch of.
I mean, I would imagine a controller that monitors for deletion of bucket objects and bucket contents. And so as soon as all the bucket objects pointing to a bucket content disappear, that's a signal that whatever the deletion policy is for that bucket content should be enforced. Meaning if it's auto delete, delete it.
Right. Okay. Just making sure we capture that here.
So about having an application owner option, yes or no, I think, you know, both work. There might, I'm trying to think if the one application might be more opinionated in, so when I delete the application namespace, I actually want to have the data also being deleted, but
I
I'm not
think
really
there's a little bit of a kind of, what I would like to see in addition to this is in the bucket content, you could have a whitelist of namespaces that are allowed to access this bucket content. And so that way, you as the administrator can say only, you know, my namespace, creator namespace is allowed to access this if you really care.
I think we have it, like
So
binding control.
let me actually, we were spitballing this. It's a little rough.
Yeah.
Okay.
Yeah, but then, so sorry, we were calling it OB in the old thing, but. Right. So in this, we kind of named it bucket policy, so in a similar fashion. But yeah, a list of namespaces, list of permissions, and because object stores allow for granular targeting of data, with these you can specify, you know, object 1, object 2, and the policy for this would say, you know, this namespace foobar and fuzzbuzz can read and write objects 1 and 2. Foobar is allowed to list all objects, for instance.
But John, I think this is the data access. Let's start with the binding control
Yeah,
one.
my bad. I'm mixing these up. Anyway, yeah, a similar version of this can be translated up to a Kubernetes control layer for binding control, such that you know, you can specialize, or you can specify in here which namespaces can bind to this bucket content to begin with.
And what does binding control mean here? What is foobar?
Foobar being a namespace, binding control,
got it.
illustrating, yeah, allowable namespaces.
And so if you,
I think on the control of objects, just quick feedback here, rather than listing objects, maybe making it around prefix and suffixes. So it looks more like traditional policies, I guess, rather than, and that way you can target multiple objects under a prefix and a suffix, right?
Yeah, true. I mean, that's something that's easily doable.
so taking a step back, I do like the direction of this. This is kind of something I thought about earlier, but one of the drawbacks of this approach, I want to run by, make sure everybody's okay with it, is we said that we want to make it easier, the brownfield case or the driverless case, because it tends to be more common that a bucket already exists. And so in order to make the brownfield case work, when you create a bucket object, you need to have a identifier for a bucket content to use. Is that okay? Is that you know, too much? Is it not too painful for the user to figure out?
So yeah, that is the question, because it comes down to now, should users be allowed to list the bucket content objects in the cluster, right? Before we were abstracting that with bucket classes. I'm not an extensive user of objects. I think guys probably got more expertise on this, but my own experience, you're able to list all the objects within, or all the buckets rather, within the like organization that you belong to. So if you're a user in, a GCS org, you can list and see all the buckets that are in there. You may only have access to a few of them.
But if you're sharing a cluster between multiple orgs, being able to list all the bucket contents, would that be problematic?
Right. So I think it might be, because if it's really considered different accounts in terms, so if a single cluster appears as different accounts or different, separation of security roles or something like that, then it might not be desired that you just list everything. However, it might be just like storage classes, right? Or is that different?
Yeah, I guess here you either need the bucket classes again or separate bucket content. Like if you want to control more high control, right? If you want namespace 1 to be able to list, but you don't want namespace to be able to list, and you want to control that maybe through either a policy or different set of credentials, then maybe even though buckets have the same name on their respective namespace, maybe they'll have to bind to a different bucket content, right? Because the administrator chose to control no listing for this namespace for this application, but this other namespace does have write read if it knows the key, or I don't know.
Yeah, but there's no good clean way to say, bucket content 1, 2, and 3 are allowed by namespace A, and 4, 5, 6 are allowed by namespace B for viewing.
Yeah, that also goes into the problem with existing buckets, that if the application is trying to say, I need a bucket with this pretty common name, let's say logs, but the administrator ultimately knows that in the cloud service, the log bucket is called company _ prefix _ logs, right? How that mapping of names will happen, that's also something that it will be interesting to discuss, because even though applications are trying to expect an application under a defined name, right? That may not automatically translate to the final name on the cloud service.
Right. So we are, the one option is to represent names just as if they are, so have no bucket content, right? For example, and then refer directly from the bucket to the external bucket in the cloud service identity. But the layer of mapping names between bucket content and the external buckets allows the administrator a way to publish something without necessarily having to conform to what the cloud service is, how the cloud service is exposing it, right? So you can say, here's my logs bucket, right, for this cluster. That's the name of it, right? Because this is the cluster and this is the logs bucket.
And that's the way it works on the volume side. It becomes a new abstraction where the application only cares about the Kubernetes abstraction of it, not the actual underlying implementation necessarily.
Right. So in terms of separating the internal cluster mapping is actually a good thing, because it's a burden on somebody, which we would like to automate and help, but it is helpful if you want to assign things. So it's like a namespace for buckets, right? This cluster has a namespace for the buckets. We even we suggested without really thinking through that there will be like there's a service name namespace.svc cluster local. There will be like a bucket dot namespace dot the string bucket to represent like services, so that like bucket contents can be even published to DNS. Their endpoint can be published to DNS, for example, so that it's like having a namespace of buckets that this cluster represents. I'm sure that it's not really well designed for multiple tenants in this case, but we need to think it through. How do we want to support tenants in clustered resources? I'm not sure how does it work with other Kubernetes cases. Perhaps if you have examples, it will help to apply.
Yeah, on this diagram, you didn't you removed a bucket class because it's kind of like you think it's no longer needed, or was there any reason to remove bucket class?
In our current thinking, bucket class is primarily used for configuration of new
Creation.
buckets. Yeah, so
Okay.
if the bucket already exists, there's no configuration that needs to be done. And in addition to that, the bucket content object will store in the greenfield case, it's a snapshot of the bucket class. So all the relative fields that are in the class should also be in the bucket content object.
Okay.
Yeah, I think going back to my comment about being able to list all the bucket contents, whether that's an issue, I think an argument can be made that if you are concerned about that, maybe the bucket contents that you expose within a single cluster, need to be scoped such that everybody who's on that cluster should be allowed to see them. And if you have two tenants that you don't want to be able to see each other's bucket content, they should not be sharing a cluster.
But well, you can control that through the bucket bindings, right? Like that they were mentioning, showing on the previous slide.
Even without the bindings, just like the ability to list bucket contents, right? The ability for me to know as an end user that a bucket content foo exists is potentially sensitive.
You think like identifiable information is leaked out just by figuring out the bucket content names?
Yeah, and it may not be actual access to the bucket, but just the existence of the bucket based on the name or things like that could be sensitive.
Yeah. So yeah, I get what you mean. So, but then
is
that's
it the
why
same with
last
PVs?
Time, is it the same as PVs? That's a good question.
I mean, PVs have a generic name, and you really don't know what's inside the PV unless someone names the PV classified data or something like that. So I was asking about the mapping between desired bucket names and actual bucket name, because it all comes down again to even that listing operation, right? So where you say some people may be allowed to list and some people may not be allowed to list. And on the S3 standard, that's already taken care of by policy, right? So that's why I was thinking that for that case, you may have two bucket contents that expose different amount of access to the bucket contents, right? So, and if that's the case, that will actually means that you have two bucket contents connected to the same bucket through different policy, but they will have to have different name, right? So then the bucket content name becomes maybe not so like a commodity, not irrelevant now, right? Because even bucket content name was going to be bucket class dash random identifier, right?
Yeah, the problem with that, I think, is the brownfield case, right? Where you end up with, if you have a single bucket that you want to reuse multiple times in multiple applications, you're going to need to go and create a bucket content for each one of those, which becomes painful because you have to rely on the cluster admin to create non-namespaced objects.
Yeah.
I mean, that is the way that Kubernetes or that Volumes does it. But I think the difference that's been called out here is that the brownfield case is much more common with buckets than it is with volumes.
Yeah, but yeah, your only concern is figuring out bucket content names, right? But not trying to really control who has access to the bucket content can list or not.
I mean, potentially both.
Yeah, because if that's, I mean, we could make the assumption, and it will be a very strong assumption, trying to say that, okay, we're not going to concern ourselves with bucket listing. We expect bucket listing, bucket content to be like the default behavior for any bucket content created by the driver. And then the bucket content name could be something that even if it's listed, doesn't expose the underlying bucket name. If that's if the cloud service bucket is an attribute of the bucket content, right?
Yeah.
I'll tell you what, I think listing is a bit different than than when cloud services do it, because when cloud services do it, they do it through the serving an API call. In this case, we're talking about managing entities, and we're not really. So one way of looking at the bucket contents would be, when I connect a driver to a cloud service, let me create bucket contents immediately for all the buckets that my driver can access, right? And then I can reflect everything from that cloud service account to my cluster. That's the extreme publishing way of looking at the buckets for my cluster. But I think, and then I can list everything. Like my cluster can do any listing that I want, and it's fully capable. And I can even imagine a way where I can manage permissions to which namespaces can list which buckets, etc. I think that if we are getting to tackle the listing problem here with this API, we might need an actual API to answer to that, because by managing just entities, it will be very difficult to use RBAC or things like that to control visibility. I don't think there's a model to control visibility this way. So
yeah, I think the best option here might be to say that is out of scope, and you have to accept that being able to list all the bucket contents in your cluster is possible, and if that's a concern,
you can always generate random bucket names if that's sensitive, like a bucket. That's like, if you really have to, the bucket content can be generated,
right.
And then you don't really have to expose
you
that.
always need a secret to access the bucket, so that's not an issue.
Right.
Mhm.
But then discoverability becomes painful, because if you're obfuscating the names of the buckets and the bucket content, then if I'm coming in, creating a bucket object in my namespace, how do I know which bucket content to point to?
I think it's not solving discoverability. It's not a discoverable index if that's how you use it. If you make it opaque names, then your intention is not to use it as a discoverable index for bucket names in the cluster.
Right. So maybe we allow both use cases. If you prefer to obfuscate, then discoverability is obviously impacted, but that's what you chose. On the other hand, you can have friendly names for bucket content that are easily discovered, but we'll have to worry about how that works with collisions across namespaces and things like that.
Yeah, but bucket content is cluster scope, so I guess they will all live together on some space. So
Right,
that will be right.
Yeah. I think the concern is mostly about protocol. So if, for example, I would like to expose a bucket called logs to the cluster, and then I expose it through S3 and my applications wants GCS, then it's one thing, or the vice versa, right? So protocol would have to match for well-known.
Yeah, you can imagine every namespace having its own bucket called logs, and so we can't call bucket content logs. But we also want it to be discoverable, so maybe it becomes a hybrid of a friendly name plus some way to unique.
That's where bucket class made sense to me, because I could say logs with a class for GCS and logs with a class on S3, and then that would solve my problem. Now the driver should somehow map my logs request on S3 to the actual final bucket, which may have a different name. Yeah.
But the bucket content can have these names as well. It's the same. So the mapping is regardless. If you're using the name of bucket content or bucket class for your index, then it has the same capability of indexing things.
Right, the possibility for collision still exists.
And if you want to encode the protocol into the name, perfect. You're solving discoverability for the application, right? But it doesn't matter if it's a class or.
But even if you do that, I think there's you could have, using the same protocol, same backend, have a different logs bucket for each of your applications in different namespaces. And if that's the case, then you have collision again. So You really need a way to be able to, I don't know, encode like the unique bucket ID or something into the bucket.
So I think a logs bucket would make more sense as a sort of a greenfield passover to the admin kind of bucket, right? Rather than like a big bucket that everybody read and write from.
Correct. So ideally, it needs like a completely generated, no collision name.
Right, like pod names for any other replica server stuff. Something with like identifying the application and then adding some
Yeah.
so that the admin can actually use it later on and be able to understand it.
Right.
But then we will be back to one mapping, right, for bucket and bucket content, because now every application or any one one bucket will have a unique bucket content for it.
That's one
There
use
wouldn't
case, I
be
think.
reuse.
That's
Yeah,
the
that was
use
the
case where
from last week. Yeah.
right. So that's a use case where provisioning is most important, right? That the namespaces would actually get most of the provisioning flow, and the administrator would get most out of the not backup, but I mean archiving capabilities and being able to save logs for some amount of time or ingest them into another system for logging.
Yeah, I think we don't need to solve this problem for the admin created bucket content, right? It's up to the admin to create a bucket that doesn't collide. It's the admin's problem. The case that we have to worry about is the automatic provision case, where you create a bucket object and it provisions a new bucket content. What should the name of that new bucket content be? Ideally, I mean, we have two kind of competing concerns here. One concern is we don't want to have collisions at the cluster scope because that's obviously problematic. And the second concern is we want it to be discoverable such that if you have another namespace that wants to use this, they can easily discover it by listing all the bucket content objects. So how do we both make it collision proof, the generated name, as well as discoverable is, I think, the goal here.
I think it's the matter of the bucket class to define, right? Somehow. It's different use cases of the same mechanism. We can set one class to create completely generated suffixes for these, which means they are obfuscated and only the administrator can make sense of them in some aftermath. And on the other hand, if the bucket class says I want to strictly map let's say the external bucket name to my bucket content, then it would fail if it's taken or something like that, right? So that would be a bucket class that doesn't succeed to do always avoid collisions, but it's serving a different purpose.
Yeah, we could
Basically,
leverage. Well,
Sorry,
it seems like that would be a space where we could use templating similar to the way that CSI uses secret name templating. You can use templates to define in the parameter list in the bucket class how bucket objects are named that come out of this class. There could be a default where you can concatenate the bucket class name with the bucket name. If there's a collision, so be it. You have to handle it. But it seems like it's so long as you provide like some tools up front for administrators to define how a class should produce buckets, then that at least mitigates it to a point.
Yeah, that's a nice solution, because that's also pushing part of responsibility to the user when they do the template, right, on CSI. They say, I want to drive with these capabilities and this storage class. And if it's available, the CSI driver will satisfy that requirement. And in this case, the driver for COSI could be the same, right? So can it be satisfied? Yes, automatically, yes. Else we need an administrator intervention to come and make that request satisfiable. So then templates will start making a lot of sense.
Right. And then, of course, coupled with the dynamic name generation that Kubernetes provides anyway. That seems to handle the majority of the cases.
Yeah. So, but if we were gonna entertain the idea of templates, that will now go into the discussion of how a pod will be requesting a bucket, right? It will be requesting a bucket along with the storage class, or it will be requesting a bucket by name and a class, and see if a bucket content can figure that out. If that's the case, then the bucket resource that we are defining here per namespace may not be needed anymore. It will be more of a list of bucket contents and bucket classes. And then the bucket contents become kind of like managing buckets as infrastructure, right? So if a bucket content is there, it means there's a bucket in the cloud provider that you can access.
Right. Right. And that alone is an administrator interface to setting policies and managing buckets, right?
Right.
I think that the other layer, right, the bucket resource in the namespace layer is actually meant to give also the administrator information about who uses this bucket in the cluster, right? That's the mapping.
Yeah, but if we look at CSI, I like the example of templates because if there's a stateful set with a template that cannot be satisfied, the stateful set simply won't be scheduled, right? It will be stopped until someone takes a look at it and figures out, either updates the definition to reflect the way that the storage request can be satisfied, or the administrator goes and satisfies that, right? If they're requesting a special storage class or more space or something like that. So it could work the same way here in Cozy if the template comes from the application saying, I'm going to need a bucket with this class and this name. Is it available? If it's not available, then the administrator needs to come and say, okay, I need to create a bucket content to satisfy this requirement. And then now that I've done it once, then anything requesting that same combo of bucket by name and class, then it will be addressed by the driver automatically.
So I'm not familiar enough with the templating mechanism, so I'm not sure. But if John wants to,
Yeah, I'm sorry. I'm trying to wrap my head around precisely what you're describing here. So what threw me off is that you were saying that a pod request a bucket or request that bucket be created, which to me doesn't quite seem like what the use case. I guess it's no different from a user just needing a bucket by a specific name.
Yeah, I'm just trying to make the comparison of those CSI templates that, although imagine a template where if you're always requesting volumes of 1 GB with the standard storage class, they always get satisfied because maybe that's the default of the cluster. But if someone says, I need a storage class called SSD storage, and I need some other values for my volumes, then the pod becomes unschedulable, right? It cannot be scheduled. So an administrator needs to come and say, well, to satisfy this requirement, either I change the amount of space or I create a storage class and I change the pod to match a storage class that exists on this cluster. So that could be the same for Cozy, right? The Cozy strategy where the pod says, I need access to 1 bucket by name with this storage class, and the storage class will allow it to pick the provider or the protocol, I mean. And now that if that's already present in the cluster and the driver can satisfy it, then a bucket content will be created to satisfy that, right? And it will be connected
so
to the pod somehow.
you want to inline. You want to
Yes.
inline the bucket resource inside the pod spec.
Yes.
Yeah.
So I'm gonna share on the chat really quick. The documentation for Kubernetes has an example of maybe if you show the example.
Right, but in that example, we generally do just a claim name, right? So you're suggesting something similar to specifying the actual claim name under the persistent volume claim stanza of the pod template to directly ask for that, but instead specify a class of buckets that could be satisfied that may already exist to fulfill that request. Or are you meaning a specific bucket name?
I mean, I didn't thought about it like a family of buckets, but I guess that could also work, but maybe just one. I pasted the volume claim template on the Zoom channel chat. So if you guys want to take a look at it, and you can see here where this is a pod is requesting something that they would like to have a template for a volume called metadata or www. And they want this to be with read-write access ones. They want this storage class called my storage class, and they're requesting 1 GB. And if the storage class is not available, this pod will become unschedulable because the scheduler cannot satisfy the requirement.
But this is still a template for a claim, right? So the claim is still created. It's just an automation for a stateful set, right? To be able to define like a combination of a pod and with the PVCs.
Yeah, this template will be translated to a PVC and then kept forever over there. And that essentially tells the administrator that this pod is owning this persistent volume. So
you're suggesting that stateful sets specifically would be, or maybe
no. I'm just, because you can do pretty much do the volume claim templates also on regular pods. You can do this on regular pods, right? So anything that uses a pod can leverage this. So
right,
if a pod,
go ahead, Daniel. I think all you're getting at is that the workflow should be the same. We should be able to either specify a storage class by which our application serves from a pool, or we should be able to specify a specific bucket name in our pod template to reference a specific bucket. So the workflow should be the same as we would expect with the persistent volume, correct?
Yes.
Okay. And Guy, are you saying that's not possible, or
no? I'm still trying to understand where this fits, because I never saw the claim templates in a pod specifically. I thought it only comes as a addition to the pod. So say when a stateful set is deploying a pod and then connecting the volumes, etc.
Yeah, I think Guy's right.
Mm-hmm.
So are you suggesting?
Here's an example of like how we would do a specific persistent volume claim name in a pod to say.
No, so the pod is only mounting the volume, right? It's not really templating.
No, this isn't a template. You're exactly right.
So what you're suggesting, so if I understand what you're trying to suggest, is that we take another step and think about how do we expose stateful sets with buckets or deployments with buckets, right?
Yes.
Okay, that's a good point.
Yeah. I mean, and it also, opens the floodgates for if you are defining your pod, your deployment to be, and you want a couple of buckets for this application to be exposed, then it's part of the application, right? And if the application cannot be satisfied, it's also signals the administrator that it needs intervention, right? You often get some stateful sets and or deployments. They may be requesting some storage class that is not valid on this system, and then you need to go and update the storage class to match the ones that are available in your cluster.
Mm-hmm. So we did have a mechanism. We did it in the OBC implementation. There's a similar mechanism, which when you mount a config map, then your pod waits before the bucket request is provisioned. So in a similar way to the PVC template, that the pod is waiting for that volume to be provisioned and bound and etc. So that was doing the same sort of workflow, timeline sort of synchronization for things, so that the pod will wait for that if that's what you're intended to do. It's less direct than a volume, but it's also possible with the same tools. But I agree. I think it's a good point that we should extend it to the applications constructs such as deployments and stateful sets to see if that has a template for buckets as well.
Yeah. I also like it because it actually causes applications not to be scheduled if their bucket request cannot be fulfilled, right? Or if it can be fulfilled via a greenfield bucket, then it would just happen. As long as the class they're requesting, it's valid. And this is where, of course, if they're requesting GCS class, let's say, but the GCS class is not available on this cluster, then of course, I cannot satisfy your greenfield request at all. But if you're requesting, if the administrator says like, oh, here we use S3 class and then now it can be fulfilled automatically, right? And then the rest of the discussion that we're having still kicks in.
Right. So yeah, the entire point then is that, you know, how can we block workloads from starting until they're back in storage is available, right?
Right. Yeah.
Yeah. Yeah. And as Guy had mentioned in the previous model, and this kind of bled into the current design, we're not making specific provisions for it yet. With the OBC OB model, we had config maps that would be deterministically named based off what the bucket name would be. So you could define your pod to say, I need this config map. The config map would not exist until the storage was, you know, provisioned or available, and then the pod could deploy.
I
So
think
that,
we talked about kind of this being an end goal where eventually we want object and object content and all this stuff to be first class in Kubernetes, and so you could have pods hold off until any reference to these objects were complete. And in the meantime, kind of for prototype, we were talking about potentially doing a CSI adapter layer, which would effectively give you the same behavior of the pod holding off.
Yeah.
Yeah.
Ultimately, this comes down to a conversation we need to have around automation, right?
Yeah.
'Cause so long as the APIs support the provisioning, how do you get that data to the pod through CSI, through becoming a first-class citizen, or through, you know, as a first step, a hacky config maps and secrets or something.
Yeah, but we could even leverage, like, I mean, if we come with a cozy bucket templating standard, that could also say, you know, I'm requesting bucket logs, and I'm expecting these values to be placed under these config environment variables right away, right? So that will reduce the need for knowing the config map ahead of time, and the cozy runtime will be doing the mappings that you're requesting.
Yeah, I think that's, let's talk about that when we kind of have a fix on the rest of the API about how are we going to integrate it with pods. I think we're in agreement about the end goal here, which is have pods be able to hold off until the buckets are ready to be consumed. But the details of exactly how we do that, let's discuss that after we kind of have fixed the rest of the API. And is there one-to-many buckets? Is there, you know, one-to-one? All the rest of this.
Yep.
Right.
I think the big high-level takeaway from today's meeting is I think everybody on the call seems to be in consensus about a many-to-one mapping from bucket to bucket content. There is some question about the generated name for bucket content. What is that going to look like? I think Guy had a proposal around a strategy kind of approach where bucket class could specify different strategies for generating that name. I think we need to flesh that out. And I'd also like to run this by Andrew and Sean and make sure they're okay with this new approach. Hopefully they can attend the next meeting.
Right. That, yeah. Speaking to that, offline, I'll shoot you an email and we can figure out a workable time for the next
Sounds
meetings
good.
here. Okay.
Cool.
Let's go ahead and wrap it up then. We're already 1 past the hour. I went ahead and cut the recording.